If I told you that our planet is not the only place to find them? The universe, it turns out, has been making diamonds on a scale we can barely imagine. When you look up at the night sky, you see a vast darkness dotted with tiny points of light. It can feel empty, silent, and far away. But that emptiness is an illusion. The cosmos is a bustling, dynamic place full of incredible objects we are just beginning to understand. We live in a cosmic neighborhood filled with what you might call spaceballs. These are not simple, empty spheres. They are planets, moons, asteroids, and comets, each with its own story and its own unique composition. Our own solar system is a perfect example. We have rocky planets like Earth and Mars, and giant gas planets like Jupiter and Saturn. Each one is a world of its own. These spaceballs are the building blocks of the universe. Think of them as cosmic islands floating in the sea of space. Some are huge, like our sun, a star that is a giant ball of burning gas. Others are much smaller, like the meteorites that sometimes fall to Earth. These are rocky fragments left over from the formation of our solar system, like cosmic fossils. And then there are the truly gigantic structures, the vast, swirling clouds of gas and dust that float between the stars. These are called nebulae, and they are the birthplaces of new stars and new planets. They are cosmic nurseries where the next generation of spaceballs is being created. What is truly amazing is that these different cosmic objects are all made from the same basic ingredients. The universe is surprisingly simple in its construction. The same elements that we find here on Earth, like carbon, oxygen, and iron, are found everywhere, in distant stars and faraway galaxies. It is just that in space, these elements exist under conditions that are very different from what we experience. The temperatures can be millions of degrees or close to absolute zero. The pressures can be so intense that they could crush anything we know. It is in these extreme environments that nature can perform its most incredible alchemy. So, when we talk about looking for diamonds in space, we are not just guessing. We are following the ingredients. The main ingredient for a diamond is carbon, and carbon is one of the most common elements in the universe. It is forged in the hearts of dying stars and then scattered across the cosmos. This cosmic carbon becomes part of new stars, new planets, and the clouds of dust that drift through space. If the conditions are right, if there is enough pressure and enough heat, this ordinary carbon can be transformed into the most extraordinary of gems. The universe is a giant jewelry box, and we are just starting to peek inside. To understand how the cosmos can create diamonds, we must first understand the recipe here on Earth. The creation of a diamond is a story of transformation. It starts with the element carbon. Carbon is a very versatile atom. It can bond with other atoms in many different ways. In its common form, like the graphite in a pencil, its atoms are arranged in flat sheets that slide past each other easily. This is why graphite is soft and gray. But to become a diamond, these carbon atoms must be rearranged into a much stronger, more stable structure. This requires two key ingredients: immense pressure and high temperature. Imagine being buried more than 100 miles beneath the surface of the Earth. Down there, in the planet's upper mantle, the weight of all the rock above you creates an incredible amount of pressure. It is thousands of times greater than the pressure we feel at sea level. The temperature is also extreme, often exceeding 2,000 degrees Fahrenheit. Under these intense conditions, the loose sheets of carbon atoms in graphite are crushed together. They are forced to abandon their old bonds and form a new, tightly knit, three-dimensional crystal. This new structure is the diamond, where each carbon atom is strongly bonded to four of its neighbors, creating a powerful and rigid lattice. This process is not quick. It takes millions, sometimes billions of years for these crystals to grow. They slowly form, atom by atom, deep within the Earth's fiery heart. They are like time capsules from a long-lost era of our planet's history. Once formed, they can remain trapped in the mantle for eons. Their only way to the surface is through a special kind of volcanic eruption. These eruptions are incredibly fast and violent, like a cannon shot from the deep Earth. They blast a pipe of rock called kimberlite straight to the surface, carrying the diamonds along for the ride. This rapid journey is crucial because if it were too slow, the diamonds would turn back into graphite. Now let's take this recipe and apply it to the cosmos. The universe is a place of extremes, with conditions that make the Earth's mantle seem tame. Inside a giant planet, the pressure can be millions of times greater than Earth's atmospheric pressure. The core of a dying star can be hotter than anything we can create in a lab. These are the kinds of cosmic kitchens where diamonds can be cooked up on an unbelievable scale. The same fundamental physics applies. If you take a lot of carbon and subject it to enough heat and pressure, you will get diamonds. The universe has all the necessary ingredients and all the necessary force to make it happen. Our own sun is a star, a giant nuclear furnace that turns hydrogen into helium, releasing the energy that warms our planet. But stars are not all the same. Some are much, much bigger than our sun. When these massive stars reach the end of their lives, they do not just fade away, they go out with a bang in a spectacular explosion called a supernova. For a brief moment, a single supernova can outshine an entire galaxy. This explosion is one of the universe's primary forges. It is so powerful that it creates most of the heavy elements, including the carbon that is essential for life and for diamonds. The supernova blasts these newly created elements out into space at incredible speeds. This material, enriched with carbon, travels across the cosmos and mixes with the vast clouds of gas and dust that lie between the stars. These clouds, or nebulae, become the raw material for the next generation of stars and planets. Within these swirling clouds, tiny grains of dust can form. Scientists have studied meteorites that have fallen to Earth and found something amazing inside them: nanodiamonds. These are diamonds so small that you would need a powerful microscope to see them. They are thought to have been created in the chaotic, high-pressure environment of a supernova explosion. But there is another, even more exotic way for stars to make diamonds. Consider a star similar to our sun after it has used up all its nuclear fuel. It will collapse under its own gravity and become a white dwarf. A white dwarf is an incredibly dense object. A spoonful of its material would weigh more than a car. It is essentially the hot, dead core of a former star. For billions of years, this white dwarf will slowly cool down. As it cools, the material inside it can start to crystallize, just like water freezing into ice. If the star was rich in carbon, which many are, this crystallization process could turn the entire core into a single gigantic diamond. Imagine that, a star-sized diamond floating in the silence of space. Astronomers believe they have found evidence of such an object. There is a white dwarf star named BPM 37093, nicknamed Lucy after the Beatles song Lucy in the Sky with Diamonds. By studying the way this star vibrates, astronomers have concluded that its interior has crystallized. They estimate that this cosmic diamond would be about 2,500 miles across and would weigh 10 billion trillion carats. It is a gem of such staggering proportions that it challenges our very idea of what a diamond can be. It is a true jewel of the cosmos, a monument to the life cycle of a star. The idea of a planet made of diamond sounds like something from a science fiction story. But, the laws of physics suggest that such worlds could actually exist. The recipe for a diamond planet is straightforward, at least in theory. You start with a solar system that is very rich in carbon, much richer than our own. In our solar system, there is more oxygen than carbon. But in some star systems, the reverse could be true. These would be carbon-rich systems, and any planets that form there would be made of very different materials than the rocky planets we are familiar with. They would be carbon planets. On a carbon planet, the geology would be completely alien to us. Instead of mountains of silicate rock, like we have on Earth, you might find mountains of diamond and silicon carbide. Instead of rivers of water, you might have rivers of liquid hydrocarbons, like oil or tar. The surface could be covered in a layer of graphite, which is another form of carbon. But deep beneath this gray surface, the immense pressure from the planet's own gravity would work its magic. Just as pressure creates diamonds deep inside the Earth, it would create them on a planetary scale inside a carbon world. The mantle of such a planet could be a thick, shimmering layer of solid diamond. Astronomers believe they have found a candidate for just such a world. It is a planet called 55 Cancri E, orbiting a star about 40 light-years away from us. This planet is a super-Earth, meaning it is larger and more massive than our own world, but still rocky. It orbits its star so closely that its year lasts only 18 hours, and its surface is incredibly hot. Based on its size and mass, scientists have calculated its density. The data suggests that this planet is extremely rich in carbon. One popular theory is that a large fraction of the planet's interior, perhaps as much as a third of its mass, is pure diamond. Think about what that means. A planet where a gem we consider rare and precious is one of the most common building materials. It is a world with a heart of diamond, a celestial treasure of unimaginable value. While we cannot travel to 55 Cancri A to confirm this theory, its existence opens up a whole new way of thinking about planets. It reminds us that the universe is far more diverse and surprising than we might expect. Not all planets are like Earth. Some may be worlds of water, some of lava, and some, just maybe, are glittering spheres of diamond, silently orbiting a distant star. It's a beautiful thought, a universe filled with such possibilities. We do not have to travel to distant star systems to find cosmic diamonds. Sometimes the cosmos comes to us. Every day, tons of dust and rock from space rain down on our planet. Most of it burns up in our atmosphere, creating the fleeting streaks of light we call shooting stars. But occasionally a larger piece survives its fiery descent and lands on the ground. We call these objects meteorites. They are messengers from the void, time capsules that carry clues about the history of our solar system and the universe beyond. And sometimes, locked inside these ancient rocks, we find diamonds. These are not the large, clear gems you would find in a jewelry store. Most meteorite diamonds are tiny, often microscopic. They are known as nanodiamonds because their size is measured in nanometers, or billionths of a meter. For a long time, scientists believed these tiny diamonds were formed by the immense shock and pressure of the meteorite's impact with another object in space or with the Earth itself. The sudden, violent collision could provide the necessary force to transform carbon inside the meteorite into diamond. This theory explains many of the diamonds found in meteorites. It's a story of cosmic violence creating something beautiful. However, some meteorite diamonds tell a different, even more fascinating story. By analyzing the chemical makeup of these tiny gems, scientists have found that they are different from Earth diamonds. They contain isotopes, variations of elements, that could only have been formed outside of our solar system. This means that these diamonds are pre-solar grains. They are literally stardust. They formed in the atmospheres of ancient, long-dead stars or in the explosions of supernovae before our sun and planets even existed. For billions of years, these tiny diamonds drifted through interstellar space as part of a giant dust cloud. Eventually, this cloud of gas and dust collapsed to form our solar system. These ancient diamonds were swept up in the process, becoming trapped inside the asteroids that were forming at the time, and then, after another few billion years of orbiting the sun, one of these asteroids broke apart, and a piece of it fell to Earth as a meteorite. When we find one of these pre-solar diamonds, we are holding something truly extraordinary. We are holding a piece of a star that died before our sun was born. It is the oldest object you will ever touch, a direct physical link to the cosmic events that created the very atoms that make up our world and our bodies. For centuries, the story behind a jewel has been almost as important as the jewel itself. A diamond from a famous mine, a pearl once owned by royalty. These stories add a layer of romance and significance that makes the piece unique. Now, just imagine a new kind of story. A story that is not just about the history of our planet, but about the history of the universe. This is honestly the incredible promise of cosmic diamonds. For a jewelry lover, the idea of wearing a gem that was forged in the heart of a star, or that traveled through space for billions of years, is profoundly exciting. It transforms a piece of jewelry from a simple ornament into a personal connection to the cosmos. The allure of these diamonds goes far beyond their physical beauty. A diamond from space carries with it the grandest story of all, the story of creation. A nanodiamond from a meteorite is a tiny piece of stardust, a relic from a star that burned brightly long before the Earth was formed. A fragment from a potential diamond planet would be a piece of an entirely different world, a testament to the incredible diversity of the universe. Wearing such a gem would be like wearing a whisper from the cosmos. It would be a constant reminder that we are part of something vast, ancient, and magnificent. The value is not just in the carat weight, but in the cosmic weight of its journey. This new narrative could really redefine what we consider precious. For a long time, the ideal diamond has been a large, flawless, colorless stone. But a cosmic diamond might look very different. It might be small, dark, and full of inclusions, but these flaws would not detract from its value. They would enhance it. They would be the marks of its incredible journey through space and time. A tiny inclusion could be a speck of interstellar dust. A strange color could be the result of radiation from a nearby star. Each imperfection would tell a part of its epic story, making it more personal and more fascinating than any perfect stone. This shift in perspective is exciting for both jewelers and their customers. It opens up a new world of meaning for personal adornment. A piece of cosmic jewelry would be more than just a status symbol. It would be a conversation starter, an object of wonder, and a source of inspiration. It would invite us to look up at the night sky and feel a sense of connection. It would remind us that the same elements that make up the distant stars and planets are also within us. A cosmic diamond is not just a stone, it is a piece of the universe that you can hold in your hand and carry with you, a tangible link to the great cosmic ballet. The arrival of cosmic diamonds, even in small quantities, could spark a revolution in jewelry design. Traditional jewelry often focuses on showcasing a single perfect gem. But how do you design a piece around a stone whose primary value is its story? Jewelers would be challenged to think in new ways, to create designs that honor the celestial origin of the material. The focus might shift from simply displaying a stone's sparkle to creating a setting that tells its incredible story. The design itself could become a miniature work of art that celebrates the cosmos. Imagine a pendant designed to look like a tiny solar system, with a small meteorite fragment at its center, or a ring that evokes the swirling dust clouds of a nebula, with nano-diamonds scattered across its surface like newborn stars. Designers could draw inspiration directly from astronomical images, the colors of a supernova remnant, the spiral arms of a galaxy, the cratered surface of an asteroid. The materials used in the setting could also be chosen to complement the cosmic theme. Metals like platinum or titanium, with their modern, space-age feel, could be combined with the dark, ancient rock of a meteorite. Cosmic diamonds would also encourage the use of new techniques. Because many of these diamonds are so small, jewelers might need to develop innovative ways to set them. Instead of traditional prongs, they might embed a fine dust of nanodiamonds into a clear resin, creating a surface that glitters with captured starlight. They could use advanced technology, like three-dimensional printing, to create intricate and complex settings that would be impossible to make by hand. This fusion of ancient cosmic material with cutting-edge technology would result in pieces that are both timeless and futuristic. This new design philosophy would also be more inclusive. Not everyone can afford a large, flawless Earth diamond, but a piece of jewelry containing a small fragment of a diamond-bearing meteorite could be more accessible. Its value would be based on its story and the creativity of its design, not just on its size. This could open up the world of fine jewelry to a wider audience, allowing more people to own a piece of the universe. It would be a democratization of wonder, where the focus is on the incredible journey of the material, from a distant star to a personal treasure worn close to the heart. While the idea of wearing a diamond from space is incredibly romantic, the reality of obtaining these gems presents a monumental challenge. The journey from a cosmic concept to a tangible piece of jewelry is long and difficult. First, we have to find them. While meteorites fall to Earth all the time, finding them is like searching for a needle in a global haystack. Most fall into the ocean or in remote, uninhabited areas. Meteorite hunters spend their lives scouring deserts and ice fields, places where the dark rocks stand out against the landscape, in the hope of finding one of these celestial visitors. Once a diamond-bearing meteorite is found, the work has only just begun. Extracting the diamonds from the surrounding rock is a delicate and complex process. These are not large gems that can simply be popped out of their matrix. The nanodiamonds are microscopic and must be separated from the rest of the meteorite using powerful acids and centrifuges. It is a painstaking laboratory procedure that requires immense skill and patience. The amount of diamond recovered is often tiny, a fine dust rather than a solid stone. This scarcity and the difficulty of extraction are what make these materials so incredibly rare and precious. The challenges multiply when we consider more exotic sources, like diamond planets. A world like 55 Cancri is 40 light-years away. With our current technology, a journey to that planet would take hundreds of thousands of years. The idea of mining a diamond planet belongs firmly in the realm of distant future science fiction. It is a beautiful and inspiring idea, but it is not something we will be able to do anytime soon. For the foreseeable future, our only source of cosmic diamonds will be the meteorites that have made the journey to us, these free samples delivered by the cosmos. But these challenges should not discourage us. They should inspire us. every great human endeavor, from climbing the highest mountains to exploring the deepest oceans, began as a daunting challenge. The quest for cosmic diamonds is part of our larger quest to understand the universe and our place in it. The search pushes our technology forward. The analysis of these materials teaches us about the formation of stars and planets. And the dream of one day reaching out to these celestial treasures fuels our imagination and our desire to explore. The challenge is part of the story, and it makes the reward, no matter how small, even more meaningful. In the end, our fascination with cosmic diamonds is about more than just jewelry. It is about connection. For all of human history, we have looked up at the stars and wondered. We have told stories about the constellations. We have navigated by the light of the North Star, and we have dreamed of traveling to other worlds. The universe has always been a source of awe and inspiration, a vast and mysterious canvas for our imagination. A cosmic diamond makes that connection tangible. It brings the universe down to earth and places a piece of it in our hands. It's a reminder that we are not separate from the cosmos. We are a part of it. Imagine wearing a ring that contains dust from a star that exploded billions of years ago. When you look at that ring, you are not just seeing a beautiful object. You are seeing evidence of the great cosmic cycle of birth, death, and rebirth. The carbon in that diamond was forged in the heart of a star. That star died and scattered its elements across space. Those elements eventually came together to form our solar system, our planet, and ultimately, us. The carbon in your body and the carbon in that diamond share a common stellar ancestor. You are, quite literally, wearing a piece of your own cosmic family history. This perspective can change the way we see ourselves and our world. It can inspire a sense of wonder and humility. It reminds us that our lives, our problems, and our triumphs are all part of a much larger, much grander story. In a universe of diamond planets and exploding stars, we are a small but precious part of the cosmic tapestry. Wearing a piece of that tapestry is a powerful statement. It is a celebration of science, of exploration, and of the human desire to reach for the stars. It is a way of carrying the wonder of the night sky with you, even in the middle of the day. So the next time you look up at the vast, dark expanse above, remember that it is not empty. It is a celestial workshop, a cosmic jewelry store filled with wonders we are just beginning to discover. The universe is constantly creating, constantly transforming ordinary matter into extraordinary things. And as we continue to explore, we may find new ways to bring these celestial treasures into our lives. A diamond from space is more than just a gem. It is a promise, a possibility, and a personal piece of the magnificent star-filled universe we are lucky enough to call home. Please don't forget to subscribe to Gemstone Academy for more deep dives into the world of gems and jewelry.